Hi, Chris Kuzmal here. We're continuing to extend our testing of our force computations. We have tested in the x direction, we've tested in the y direction. Now we're hoping to test in both the x and the y direction. We have a method called test force at a distance, but I'm going to change the name of that to be test x force at a distance because that's what it's doing. That means I also need to change the name of the invocations we see by changing that name. All the test force at a distance or test force at a distance V methods anyway have been now fall into error because by changing the name of the definition of the function, the invocation becomes erroneous. So I changed the invocations as well, and I should run as well. That's a tiny little change, but it's a good idea to check it. And actually, I have this n-body loop going on, which gives an intuitive check that kind of helps us see whether or not things are running without actually making precise measurements. Our tests, our individual tests up here on line 20 and 23 and so on, are doing individual sort of tests of individual pieces of information, while our loop, which is still available for us to run, kind of shows us the big picture, but doesn't necessarily identify individual errors. The change did not produce any errors. That's lovely. Now what I'd like to do is do a test. Again, I feel uneasy. I'm doing this copying and pasting. We're definitely going to need to have a refactoring session later on. And the overall lesson I will mention to you in advance that we're going to learn there is, and it's very hard psychologically, at a certain point in time, you should probably just throw all your code away and start over. And I mean, we haven't been doing a terrible job of writing our code to this point. Nevertheless, we have been copying and pasting, and if we can change what's going on in our own minds to the point where we really understand how to do our code, we will come to recognize that we should create certain abstractions and certain encapsulations that make our code more reliable. But for the moment, we carry on because we can. And now we're going to test, I guess I'll call it test XY force at a distance. Okay. And now what do I expect to have happen here? I'm going to have an expected force. I'm going to have a distance X as an argument, and I'm going to have a distance Y as an argument. And I'm going to create my second object is going to be at distance X, Y. Distance X and distance Y is going to be its location. Okay. Now, oops. And I'm going to compute the X force and the Y force. So I have an actual X for my value, and I'm going to have an actual Y. So what I've done here, oops, I didn't write actual Y, and I didn't invoke compute Y force. So what I've done here is I've created objects at the origin in the case of what's on line 54. On line 55, created an object at location distance X, distance Y. Then I proceeded to compute the actual X force and the actual Y force between those two, or the computed forces between those two objects in the X and Y dimension, and store those into variables actual X and actual Y. But what I lack is a solid, a meaningful test, because I have an expected force. The expected force is a single number. Really, I would. There's a couple of options here. One is I could talk about the expected total force, which is a reasonable idea, or I could talk about the expected X force and the expected Y force, which I think is probably more straightforward. So that means I have an expected X force and an expected Y force as well. So I have yet another argument, double expected Y force, comma. But now my check on line 59 is not adequate. I need to check to see whether or not the X force is correct. I need to check to see whether or not the Y force is correct. And so we'll introduce that code in the next video.